Hello students, welcome to EPG Pathshala. I am Gaurav Gupta from Sharda University. Today we are going to talk on module Acceptance Sampling from Paper Operations Management. Objectives. This chapter will enable the students to understand the concept of acceptance sampling, situations where acceptance sampling is used and the risks associated with it. Operating characteristics of different sampling plans: single sampling plan, double sampling plan, and multiple sampling plan. Advantages and limitations of acceptance sampling. Introduction. Every manufacturing organization strives to ensure that the finished product meet the standard specifications defined either by the manufacturer or the consumer. The extent to which the product manufactured meets the standard specification describes the quality of the product. For a business organization to become successful, it is must on its part to offer quality products to its consumers. It necessitates the needs of the effective quality control system in the manufacturing concerns to ensure that the products conform to the specification and meet the customer's requirements. However, the inspection method, which include inspection of each and every unit of production to ensure quality of the product, is costly affair in terms of money, time, and labor. Moreover, the repetitive inspection process causes boredom and fatigue, and as a result, there is always a possibility that even the competent and efficient inspection may overlook some defective items. Inspection method is also not suitable in the cases where the products manufactured and destructive in nature. Example: life of a bulb, explosive strength of crackers, or life of a candle. Thus, in the cases where the inspection method is not suitable, statistical sampling inspection method can be employed to determining the quality of products manufactured. Acceptance sampling is a statistical technique which involves decision for accepting or rejecting lots, batches based on inspection of samples. Meaning: acceptance sampling is one of the important techniques of statistical quality control. This technique encompasses decision for accepting or rejecting a lot or batch of product that has already been produced or is in final stage of production, or the basis of sample for the product. The quality of the whole lot is presumed to be good if the sample meets the specified standards of quality. In other words, it is a process to measure the quality of a batch with a specified degree of statistical certainty without inspecting every unit of product. Since this method is based on samples, thus it also known as sampling inspection plan. The basic assumption underlying acceptance sampling is that the sample is randomly selected and includes the products of varying qualities from the lot. However, there is always a probability that the sample is accepted but the quality of the batch is bad or the sample is rejected, but the quality of the batch is good. But by increasing the batch size, increasing the sample size, or by inspecting more than one sample, more reliable conclusion can be made and better decisions for accepting or rejecting the lot can be taken. Acceptance sampling should not be confused with statistical process control. Statistical process control aims at improving the process so that future product can be improved. On the other hand, acceptance sampling relates to evaluation of products after their production to ensure their quality. Three basic determinations involved in acceptance sampling are batch size, sample size, and maximum number of defects to be uncovered for rejecting the entire lot. The basic procedure involved in acceptance sampling is a random sample is taken from a large quantity of items and its quality characteristics such as height, radius, etc. are measured. If the selected sample passes the test, then entire quantity is accepted. If the sample fails the test, then either quantity is subjected to 100% inspection and then all defective items are found, which are then either reworked or rejected. This is costly and time consuming procedure. Another way around this is that quality manager resort to multiple sampling plans, which involves taking another sample from entire quantity and its quality characteristics are checked. Such sampling plans would be discussed in next section. The entire quantity is rejected and returned. Decisions involved in setting up acceptance sampling plans. Acceptance sampling involves decisions from both consumer and manufacturer. The producer would like its lot of accepted by consumer without being reworked or rejected. The consumer would only accept if the lot given by the producer is defect free. Consumer would like to reduce the risk of rejecting good quality lot or accepting bad quality lot, as the entire lot when items are large number rarely be 100% defect free, so there would always be some likelihood of having few defective parts. Thus, in this scenario, both consumers and producer reach an agreement in deciding acceptable number of defective parts in one lot. Following definitions or concepts needs to be understood while making such decisions. Acceptance quality level AQL. It is maximum percent defectives that can be considered satisfactory for the purpose of sampling inspection. The level represents the maximum proportion of defectives that can be accepted without any major effect on further processing or customer relation. It can be considered as producer's safe point. For example, an agreement between producer and consumer might call for acceptable level of one defective item per 10,000 items, indicating an acceptable level of 0.0001. It is pertinent to mention here that acceptable quality level indicate number of defective items per lot and number of non-defective items. But in case even with such low level of acceptance level, the lot gets rejected or not accepted by consumer due to faulty sampling plan, then it would lead to loss of producer. Such a risk is termed as producer's risk, and probability of happening of such case, that is rejection of good lot, also called as type 1 error, is denoted by alpha. Generally, most of sampling plans work with 1% of AQL, implying that probability of occurrence of type 1 error or produces risk in sample of items in 1%. Lot tolerance proportion defective LTPD. The LTPD, also known as rejectable quality level, that is RQL, represent a designated high defect level which would not be acceptable to the consumer. At this level, the consumer wants to be quite sure that the lot will not be passed. It represents that worst level of quality that consumer will tolerate. LTPD is the definition of bad quality that consumers would like to reject. But in case such a lot with unacceptable level of defective items is passed or accepted by consumer due to faulty sampling plan, then that would lead to loss of consumer. Such a risk, known as consumer risk, and probability of happening of such case, that is acceptance of bad lot, also called as type 2 error, is denoted by beta. Generally, most of sampling plans works with 10% of LTPD level, implying that in a sample of items, the chance of occurrence of type 2 error or of consumer's risk is 10%. The above mentioned concepts are based on two important criteria. Firstly, selection of proper sampling plans. Next section discuss three different types of sampling plans. Secondly, performance of a particular sampling plans in analyzing discrimination between good and bad lots. This is done by calculating probabilities of type 1 and type 2 error for different sample size and acceptance number. This is illustrated graphically through operating characteristics curve and also by discussing few numerical types of sampling plans. There are different types of sampling plans depending upon number of samples drawn from the lot. Single sampling plan, double sampling plan, and multiple sampling plan. Single sampling plan. Under this plan, a single sample is drawn from the lot. Each and every unit of sample is inspected and the number of defectives D in the sample is noted. The number of defectives D is then compared with the acceptance number A. The lot is accepted only if the number of defected in the sample are less than or equal to acceptance number. For instance, acceptance number A of 3 in a lot size n of 50 would mean that if the number of defective D in sample are equal to 0, 1, 2 or 3, the lot will be accepted, otherwise rejected. Working of single sampling plan. Sample randomly drawn from lot n and number of defective observed. If D is greater than A, rejected the lot. If D is smaller than A, accepted the lot. Double sampling plan is used when the first sample drawn is neither very good nor very bad. This plan involves decision for accepting or rejecting the lot on the basis of combined result of first and second sample. Under this plan, firstly a sample of size n1 is drawn and number of defectives d1 in the sample are noted. If number of defectives d1 in the sample are less than or equal to acceptable number A1, the lot is accepted, and if the number of defectives D1 are more than A2, the lot is rejected. If the number of defectives D1 are in between A1 and A2, then another sample of a different size N2 is drawn. If number of defectives D1 and D2 in the combined sample of N1 and N2 is equal to or less than A2, the lot is accepted, otherwise rejected. Working of double sampling plan. Sample drawn randomly N1, defective observed. If D1 is smaller than or equal to A1, lot is accepted. If A2 is greater than D1 is greater than A1, draw a second sample N2, observe the number of defectives in second sample, calculate D1 plus D2. If D1 plus D2 is smaller than A2, accept the lot. If D1 plus D2 greater than A2, reject the lot. Third, if D1 is greater than A2, lot is rejected. Multiple sampling plan. Multiple sampling plan is characterized by drawing several samples until a decision to accept or reject a lot is taken. It can be stopped at a particular stage or can be continued till the whole lot is exhausted. Working of multiple sampling plan. Draw random sample, say 100 for inspection. If it contains 5 or less defectives, accept the lot. Defectives between 6 and 9, draw a second sample of 100 for inspection. 7 or less defective is combined sample, accept the lot. Defectives between 8 and 11 in combined sample, draw a third sample of 100 for inspection. 14 or less defective in combined sample, accept the lot. Defectives between 15 and 18 in combined sample, draw a fourth sample of 100 for inspection. And 12 or more defective in combined sample, reject the lot. Operating characteristic curve. An OC curve is graphical representation between proportion of defective items and probability of acceptance of a specific lot. There would always be some number of defective items in a lot. Two things that should be emphasized here are, firstly, number of defective items, and secondly, lot size. With change in lot size, number of defective items also change. For instance, there could be only one defective item in a lot size of 100, but with increase in size of lot to 1000, number of defective items might also increase to 10. OC curve indicates probability of acceptance with change in lot size and number of defective items in that batch of items. X-axis of the curve represent proportion of defective items and y-axis represent corresponding probability of acceptance. From the figure, it can be clearly deduced that if proportion defective is 0, then probability of acceptance would be 100%. The probability would keep falling with increase in proportion of defective items. The curve also indicates alpha and beta values. In the following figure, if the acceptable quality level is 1%, then probability of acceptance suppose is 90%. But if even with 1% AQL the batch size is rejected, it would indicate type 1 error shown by alpha in figure. Similarly, if LTPD is 10%, then probability of acceptance suppose fall to 20%. But even with such low level of acceptance, the batch should be rejected. If it gets accepted, it would imply occurrence of type 2 error shown by beta in figure. Following cases illustrate the application of OC curve by calculating values of alpha and beta for different acceptance number A and sample size n. Calculating the probability of acceptance involves decision of either item is defective or non-defective. Thus, binomial probability distribution is followed in calculation procedures. Following formula would be used. Suppose P is the probability of acceptance, N is sample size, A is acceptance number. Then use the formula. Case 1. If sample size N is constant and acceptance number varies, first, if N equal to 60 and A equal to 1, that is customer will accept a lot of 60 if number of defective items are 0 or 1. Thus, probability of accepting a lot with A equal to 1 when AQL equal to 1% would be Px is equal to 0 plus Px equal to 1. Putting the values in the formula, it comes to be 0.8786. But due to faulty sampling plan, if the lot is still rejecting, then probability of rejection of good lot indicated by alpha would be 1 minus 0.8786 equal to 0.1214. If n equal to 60 and a equal to 2, that is lot would be accepted if number of defective items are either 0, 1 or 2. Thus, probability of accepting the lot with a equal to 2 when AQL equal to 1% would be Px is equal to 0 plus Px equal to 1 plus Px equal to 2. Putting the value in the formula, it comes to be 0.9775. But due to faulty sampling plan, if the lot is still rejected, then probability of rejection of good lot indicated by alpha would be 1 minus 0.9775 equal to 0.0224. This implies that with the lot size remaining same and increase in acceptance number, probability of occurrence of type 1 error, that is producer's risk, decreases. As more defective items in the same lot size are now acceptable, so chances of rejecting the lot, which is termed as good, decreases. But this would lead to acceptance of lot with higher number of defective items, increases the chances of occurrence of type 2 error or consumer's risk. If sample size n varies and acceptance number A is constant, if n equal to 60 and A equal to 1 with AQL at 1%, then probability of acceptance of lot would be P equal to Px is equal to 0 plus Px is equal to 1. By putting in the formula, it comes to be 0.8786. But due to faulty sampling plan, if the lot is still rejected, then probability of rejection of good lot indicated by alpha would be 1 minus 0.8786 equal to 0.1214. If n equal to 80 and A equal to 1, then probability of accepting the lot would be Px is equal to 0 plus Px is equal to 1. Putting the values in the formula, it comes to be 0.8091. But due to faulty sampling plan, if the lot is still rejected, then probability of rejection of good lot indicated by alpha would be 1 minus 0.8091 equal to 1909. This implies that with change in lot size and acceptance number, same the probability of occurrence of type 1 error increases. The producer is at risk of rejecting its good lot from consumer with increase in batch size. Performance of sampling plan. Example of single sampling plan. A manufacturer receives large batches of items daily and decides to apply acceptance sampling scheme. Three possible plans are considered, each of which require a sample of 30 items. The agreement between producer and consumer indicates AQL equal to 2%. Plan A. Accept the batch if no defective items are found, otherwise reject. Plan B. Accept the batch if not more than one defective item is found, otherwise reject. Plan C. Accept the batch if two or fewer defective items are found, otherwise reject. Find probability of acceptance for each single sampling plan. Solution. For plan A with n equal to 30, p equal to 2% and a equal to 0, by using formula, probability is 0.545. With n equal to 30, p 2% and a equal to 1, by using formula, p equal to 0.879. Plan C with n equal to 30, p equal to 2% and a equal to 2, by using formula p equal to 0.978. Example of double sampling plan. With the probability of acceptance for following plan with acceptance number as 1%, take a sample of 40 and accept if no defective item is found. Reject the batch if two or more defective items are found. If one defective is found, then take a further sample of 40 items. If total of 2 or fewer defective items out of 80 are found, accept the batch, otherwise rejected. Solution. Accept the batch if 0 defective items are found in batch of 40 items. Accept if 1 in first sample and 0 in second sample are found defective. Accept if 1 in first sample and 1 in second sample are found to be defective. Thus, probability of acceptance is 0.923. Advantages of acceptance sampling. The advantages of acceptance sampling can be listed as follows. Less cost and time is required for acceptance sampling as compared to 100% inspection. Smaller inspection staff is required. Problem of boredom and fatigue which arises in 100% inspection is eliminated. A lot is disposed of in a shorter time and hence scheduling and delivery are improved. The items subjected to destructive test can be inspected by sampling inspection only. Less damage to product as only a few items are subjected to handling during inspection. Quality of a product is improved as the rejection of entire lot on the basis of sample puts much pressure on quality improvement than the rejection of individual article. Limitations of acceptance sampling. First, since the decisions of accepting or rejecting the lot are based on sample, so there is always some likelihood of making wrong decisions regarding the quality of lot, resulting in consumer's risk or producer's risk. The effective outcomes of acceptance sampling technique depends on the randomness of samples, quality characteristics to be tested, lot size, acceptance, critical, etc. It provides less information as compared to 100% inspection. Let us summarize this module. Acceptance sampling helps in assuring the quality on one hand and overcomes the limitation involved in 100% inspection. Thus, acceptance sampling allows the manufacturing organization to determine the quality of the lot with a specified degree of statistical certainty without inspecting each and every unit of product. It helps in deciding whether to accept or reject a particular lot of material purchased, or whether to pass or not to pass a particular lot of materials in process, or whether to pass or not to pass a particular lot of finished product or dispatch to customers, and such decisions are taken by inspecting samples only. Thank you.